Hello, everyone. Welcome back. Happy Friday. Seth, can you stop talking? Thank you. Well, would you please stop talking? Yes, because yes is different. I'm sorry. English is not my first language. All right. Brett wants to give you a couple of pointers on your programming assignment. Yeah.
Sure. All right. Happy Friday, everyone. I just wanted to say, first of all, really good job on the first MATLAB assignment. I was really happy grading those. I saw a lot of good things. I just, that we're going to continue to have higher expectations because we can see what you guys can do. So we definitely want to push you to grow in your MATLAB skills. The first point I have here, your time vector, right? So just for example, if you only have it going from 0 to 1, you're not going to be able to see the whole response at actually reaching a steady state. I was able to look at, your code and was able to see that it was in fact correct, but you're not able to see the whole response as opposed to if you manipulate that time vector to show a little bit more time, you can actually see it reach a steady state. So make sure, you're, considering that when you want to see the response to your system. And then 2, I gave some leeway on this. Some of you just copy and pasted your graphs into a PDF or probably a Word file, then made it a PDF. That's not going to be accepted anymore. We really want you to make a professional report from MATLAB directly. So if you're not sure how to click the export button, I know it takes some time. I've had some trouble myself. Just come see us and I can show you how to do that. But make sure you're publishing straight from MATLAB. I can tell when it's not because it just looks different. And then 3, observations for different values of J. I saw some really good observations. I saw a couple not give an observation. It's almost more important to be able to explain what's happening as opposed to just be able to write the code to get the results. Being able to intuitively understand what the results are, that's almost even more important. So make sure you're always stating your observations for your MATLAB assignments. So those are my 3 points.
Awesome. Thank you.
Yep.
All right. So with that, we can go and check your practice exam. So everybody go to Carmen. This week's module, today's lecture. I'm not going to get out of this because it takes time to come back. What is happening? Oh, hold on. I can never actually mute my iPad for some reason. I have to use a jack, so it thinks there is a headphone in there. All right, so material for the exam, everything from day 1 all the way to the end of week 6, right? Well, week 5, sorry, lecture 12. All the class participation, if it's a quiz, if it was an assignment, homework 1, homework 2, both solutions are online. If there was a practice problem, everything in the lectures, they're all gained. All right. I brought 2 problems today to solve with you. So you can kind of see there will be 2 problems on exam, but there will be a section of short answer and true false, which will be from the rest of the lecture that's not in the problem. All right. No, then tell me. All right. So any questions on that? What's the material? All right, so let's talk about cheat sheet because a couple of you asked. So cheat sheet, you can see it on Zoom, but this is a paper that you can print things on, right? So it's called A4 size or US letter, or you call it like printing paper. One side of this, handwritten, means that you grab a pen or pencil and write. You do not crop, copy, paste from your lecture on here and print. If you're an iPad user, I will let you write on your iPad file, print that. Okay, so the whole idea of writing cheat sheet is to study. So if you copy paste from somewhere, you're not studying, you're just bringing stuff to the exam. It just beats the whole point of bringing cheat sheet, all right? Now, so this is point number 1. Point number 2 is that I said you can only bring equations, right? Or write a procedure. So what does it mean? Let's say that you don't want to remember how to do feedback loop reduction, right? The equation is, so G, you have G and H, G is in the direct path, H is in the feedback path. You write T, your transfer function is equal to GH over 1 plus GH. There is no example of, let me put one S or one number and I can do it to bring something with me. So you can bring this equation, you can bring this formula, but that's it. For the analogous system, for example, you have a table, right? Force voltage, that what is input, what is output, what are the components. You can bring that, you can write that down for yourself. But if you remember for force current analogy, at the end of the lecture, I gave you 2 examples, right? For visual, you remember that slide? On the right side there, I wrote the procedure by textual. On the left side, there was an example. You cannot bring that example. You can bring the textual information because that tells you the procedure. Because when you're studying, maybe you have a specific way of solving things. You can write that down for yourself. Now, the whole idea is that I want to evaluate your knowledge, but I'm providing you some information so you don't have to memorize everything. Now, we will gather the cheat sheet with the exam. So when I'm grading, I look at your cheat sheet. Now, if someone wants to be smart and do something that's, find the loophole, I would know I'm going to grade your exam. I will grade your exam myself. He is not. All right. And then I will return you back the cheat sheet with your exam because you can use it for a second exam. Or if you wrote a really nice cheat sheet, you might want to keep it. Right. So you get that back. Sometimes when I grade, I will grade your train of thought. So you don't know how to do it, but like you know the procedure, or you run out of time, or for some reason you're stressed, you don't do the math, but you write down the procedure. So if that procedure is something that shows me the way you thought, I will give you some points. Now, if you put a formula in there that, I remember is this, and the formula is on your cheat sheet, you're not going to get any point for that. You brought the formula. So I will give points for efforts. All right. If your final solution is wrong, you will lose 1 or 2 points, but not too much. I also don't use waterfall. So if you do a mistake at the beginning, it doesn't accumulate. You just lose point. And then I grade based on the rest. Assuming your answer was correct, I grade, but you'll lose 1 or 2 points there. Okay. So I try to be fair, and I want you to, when you're writing your exam, write down all the work, all the process that you get to that point, because you might make a mistake, but you will get points for the effort that you have done. Does that make sense? Question? Yeah, conceptual mistake is different.
No, I know, but they like you're simplifying something, they something back rather than it being parallel or something like that. But then you keep simplifying that, but not like apply.
So I will take off point that I wanted to give you for feedback, and then I check the rest of what you did. But it doesn't mean like if you made it like the example I gave you like last week for your system, you had to know it's a closed loop system, right? Create the system and find the tau. So if that one you didn't know the concept, you made a mistake, you won't be able to do it. I won't give you anything, right? So conceptual is kind of different. So I still count that as like small, like math mistake or a formula mistake. So my point is like, let's say that you're writing differential equation and then one side you're supposed to divide by M1, you didn't, right? So I take off point for that because obviously your matrix is going to be wrong. But I will look at your procedure for writing that matrix. All right. So this just helps you to feel more relaxed that, hey, if I made a mathematical mistake, I'm not going to be penalized too much. I still get points for the rest of my effort. So when coming to exam, I don't want you to be stressed too much. Just think about what I learned, what is this question asking me, and then just put down whatever you remember. Okay. All right. So take a look at your practice exam that I posted. Read the first page. That's what you will see, and you have to sign. So it's better that you know what's on it right now. Yes.
I was just wondering, for the cheat sheet, when it comes to verbal definitions and whatnot, that's okay.
Put whatever you think. Yeah.
Okay.
It's fine. Yeah. So apart from page 1, I'll give you time to read the 2 questions I brought. I don't know if you looked at it or not. And then I'll start solving those. For question, the problem 1, I prefer if you start thinking about it and try to solve it. Problem 2, I picked a harder example on purpose because I want to teach you a few things when I'm doing that. But if you know how to do that, you'll be able to do anything. All right. This is really important. To receive full credit, you must show your work. I think I've taken off points in your CP even if you didn't show your work, so you should by now be used to it. It took me 20 minutes to do this exam. So 55 minutes is 2 times 20 minutes because I know what I asked, so I don't have to think about it. So 20 minutes thinking, 20 minutes writing, plus 10 minutes, 15 minutes of reviewing. So it should be fair. All right. You can bring a calculator, you cannot use your phone. So I don't think you need a calculator, but you could do by hand everything that I give you, but it makes you feel comfortable, you can bring it. Don't put equation or formula in your calculator. Done that before. Talk about cheat sheet. You cannot use laptop or anything, you cannot talk to each other. You have to write neatly. If I can't read it, I won't grade it. And my standard is from my handwriting. If it's worse than mine, he's like, yeah, I got it. If it's worse than mine, then, you know, because mine is not the best. Some of you write very neatly, like I'm very impressed. Don't look at anybody else's hand. If you have question, raise your hand. Both me and Brad will be here. You should not have questions, but if you had, you can raise your hand. On the day of the exam, if you're supposed to take the exam here, so if you're not SLDS and you'll be in the class, leave 1 seat between you and your classmates. All right. And if possible, sit on the sides outside. So if you want to leave earlier, it's easier and don't bother other students. All right. So you can still sit in between, but just try to think about your other classmates. At the bottom here, you have to sign. So let's say this is my signature. This signature matches the one that Brett collected the other day. If you haven't, who wasn't here when we did the signature? Go see Brett at the end of the class, write his signature and he's gonna give it to me. And then I'll give you back those staple to your exam. Okay. Don't forget your names and your last names here. Also, please write in a way that I can't figure out who it is because this is important. I have to put your grade on Carmen. So there will be some true, false questions. There will be some short answer. Now, whatever that is not in the problem 1 and problem 2 is game for this part. But as you can see, true, false, short questions. So it's like more conceptual, fundamental stuff, right? Things that can appear there. Did anybody take the practice exam online that I gave you? Okay, you'll see that there's like MATLAB commands that I might ask you, right? Because if you have done, yes, if you have written your own code, you remember. All definitions, feel free to write all the definitions, bring them with you. LTI system, if it's something is LTI or if it's not. If it's a true false, you don't have to prove it, right? If you did and you were wrong, I will look and then decide what you put down and then I might do something, I don't know. If it was a short answer, you have to show your work. You get that. Analogous system might appear in one of these 2. Final value theorem, initial value theorem, all the concept and definitions. How to calculate pole and zero in different ways, depending on if you're in time domain, you're in S domain, you should be able to calculate those. And writing differential equation from a transfer function or from a flow diagram. We worked on this. We have class participation on it, right? So things that you have seen before, they're all gained for this first section. Some of them might appear in problems. The problems are not exactly what I'm solving here, but this will be the type of things that you'll see, all right? So you will not spend more than 10 minutes, hopefully, on the first part for that 10 points. Should spend less, but let's say 10 minutes. Okay, read problem 1 and try to solve it. I'll give you 5 minutes and then I'll solve myself. Okay, 5 minutes should be enough at least to know what you want to do. Oh boy. Gonna go check that very quick. What is G over 1 plus GH? Wait, I need also cheat sheet. Yes. Let's write that again. All right, so the question is asking, draw the signal flow graph for this block diagram. And it's giving you some extra information that consider TD is 0. And it wants you to find the transfer function of the closed loop system as well. You can use any method. So let's do the first part, which is drawing the signal flow diagram. So we need to identify all the signals, right? And we'll identify all of our takeoff points, all the sum points, right? So those become our new nodes. And then all the transfer function becomes our branches. Now, if you have two takeoff points that are close to each other, you want to have two different nodes for them. The transfer function between them is 1. It means that it's just a line. If you remember, depend on how you draw this. If you want to use this flow diagram for something else, then you have to follow your own flow diagram. Two people might draw flow diagrams differently depending on how they treat two takeoff point next to each other or two sum point next to each other. You remember, you could get them together as one, or you could have separate and with one in between. So stay consistent with what you do, you'll be fine. I'll grade based on what you show, all right? So here, it's not going to have great impact. So I'm just gonna go and start with my first signal, which is omega d or Vn. I can even put that first between, so this is my takeoff point, this is my first one, so I can say this is 1, right? Or I could show them both as one node. It would be okay. Then I'm going to the next node, which is my sum point over there. Transfer function between is 540. Then I'm going to my next node, which is where TD is coming in. So if TD is another signal, right? I can show it like this. So I'm gonna show S+1. Now, since TD is 0, you could have said from the very beginning, this is 0, I'm not gonna even show it. That would have been fine. But if you do this and say TD is 0, so there's no signal coming in, it's again correct. Then you continue, you have another transfer function, 1/2 S plus 0.5. Then here, you can treat these two takeoff points separately and do something like this. So this is your omega, or you could say that, you know what, these two are just 1 point. That also would have been correct. So I'm gonna just show like as if I had both of them, just to show you what will happen. This will be 1 between them, and this is also 1, because here and here, there's no transfer function, but there is a signal that's connecting, so it just means 1. Then, so I got here to the end. Now I have 2 feedback. So one goes from this one to this takeoff point, to this sum point, and this is negative 0.1 because this signal is negative. I have another one from this takeoff point that goes here. This is -1 because here is -1, right? So this will become your flow diagram. Now, I might ask you how many non-touching loop this has. Like all the information from here, you have to look at what you draw. So I'm going to look at what you draw and then grade you based on that. Okay. If I ask you find the transfer function using flowchart diagram, I will do it based on what you had, because then the solutions will be different, right? Depending on how you define your node and branches. Now, this is our flow diagram. Now you want to find the transfer function. Since I give you the option here, you could choose anyway. What would you choose if you had the option? Well, you don't have MATLAB in your exam. Yes, I would choose MATLAB too. What else would you? Well, when you say MATLAB, you're actually using block reduction, right? Because that's what you code in MATLAB. So block reduction is actually your preference. So it's mine too, because it's easy, especially here. So since TDS is 0, if it wasn't, it would be a different case, like because it would be disturbance, you had to solve it separately. But thankfully here, it's easy. So you will see that. So I'm just going to write the procedure for myself for transfer function of closed loop. Let's call it, I'm going to call it T closed loop. G1 in series with G2. So T1, I'm going to say is 10 S+1. I know some of you already have that. I made a mistake here, which I have to rewrite my solution, but Now, if this was easy to multiply, do it right away. So S plus. Did I write something wrong? No, 2S. So S is 2S squared plus 2.5S plus 0.5. Now, this transfer function is in feedback with point one. So I'm showing my thought process, right? So one way is to draw those boxes. One way is to just write like this, depending on how much time you have. If you want to draw every single time, that's like 5 minutes. But you could write one sentence, what am I doing right now? So if you made a mistake, I know what you wanted to do, but things happen. So in feedback, like the mistake I did when I was doing this was that I made a mistake in that one. So T2 would be the numerator 10 over 2S squared plus 2.5 S plus 0.5 over 1 plus 10 times 0.1. Over there. Well, you cannot do this, you have to actually write it, but that's why I actually time myself how long it takes to write everything. Now, this cancels out, and this is 10 over 2S squared plus 2.5 S plus 1.5. So T2 here, now T2 in series with G3, and then unity feedback. What does that mean? Well, because this one is just one, is in unity feedback. So I multiply these two and then get the unity feedback. So my T closed loop is going to be 540 times 10 over this thing. One plus that whole thing. 5400 divided by. What did we replace? I forgot. Okay, S squared plus 2.5 S plus 1.5. Now you have to solve this, right? So you will cancel these two and then write the final, which, what was your final? It's like 5400 2S squared, because I made a small mistake there. Like 5401.5?
Yeah.
Okay, that is your closed loop transfer function. What does it mean, closed loop transfer function? This system is a closed loop system, and I found the closed loop transfer function. So this whole thing means this thing. Now, if I want to find the poles, what should I do? Put the denominator equal to 0. So if the question asks you, like if there was such question that find the poles of the closed loop transfer function for the system, you have to do all of this step to get your transfer function to find the poles, right? So that's like you understood what the concept is, and then you just do the math. All right. So that is pretty straightforward, hopefully. Question 2, well, problem 2. It is going to be about finding differential equation or state space representation, something along that line. All right. Now, one thing that I noticed in class participation, I didn't take point off. I'm sure it will appear in homework as well. I haven't decided if you should take point off or not, but I have mentioned many times, you have to read the question, well, what they asked you. If you give extra information, it doesn't mean you're going the extra mile. It means you were not sure what you're asked for, you just provided all the information. That's not how engineering works. If you want to go the extra mile, you have to mention now, in addition, if we wanted to do something, this is what the question asked, then we are doing that. What's a good example of that? If I ask you, what is this state variable equation? Which one is it? What am I asking? X dot equal to ax plus bu. If I said, what is the state space representation? What am I asking for? You also have to put the y. If you didn't have information about the y, now you say, assuming y is whatever you can define is this, right? So if you give me state space representation for state variable, you're going to lose point. Because to me, you didn't understand what I asked. It's like, I'm asking to design a position control and then you design a velocity control. You're controlling position also, right? So make sure you read the question well and then only answer that. If you want to do the extra mile to show me you understood well, mention that this is not part of the question, but we could do this. And that's fine. All right, now I'll give you a few minutes to read this question before I solve and try to see if you can find a way to solve this. For this is a mechanical system. So the question asks, find the equation of motion for this and state variable. You have to dig those, whatever method you want to use, right? My suggestion is go the way that you're 100% sure you're going to get it right. This is a very, a more unconventional way, but more realistic problem. This is actually a problem from real world, right? We simplify it. So and my goal was to show you that what we are learning applies to real world problems. Like as soon as week 7, we can solve this. Huh. We actually don't need this information.
All right, what is hard about this problem? There's no force, right? Directly. Think about, this is real world problem, right? You're driving your car, you're gonna hit a bump. So, you're going on a flat surface and then hit a bump, what happens? The car moves. That's your motion, right? What caused that motion? The bump on the road. See the road surface as a bump, so the distance from a inertial reference, if it is R, when you measure that R across your bump, it changes with time because it goes up to the peak of the bump and then goes down. You can't say that could be your RT, the inverse, the thing that caused your system to move. Either that is, or we can say that my wheel stopped bouncing because it hit on something, right? So this will help you to understand where you can start the motion, what causes or what's the input. The real life problem doesn't have, hey, F applied to the system. You have to look at it and define what it is. That's why I brought this question. So you can connect your real life problem with your knowledge and be able to solve it. Because once you have the equation of motion and state space representation, what can you do with it? You have the equation from yesterday, like Wednesday, sorry, you work on second order responses, right? You can look at response in your system. And you can control it then, because then you will design a controller that will make that response behave the way you want. So designing your controller, it really highly depends on what your system is and what is being applied to your system from the environment. So you're never gonna get barely a problem that has everything solved for you. Hey, there is an internal FT applied. These two are your state variables. This is your output. Most of the time you will define that, which is system identification, simulation problems, then you'll solve control problem, right? So for here, now if we solve that little problem there, like little thing that wasn't very clear, then we know where the force was generated, then everybody now knows. Free body diagram, I know which part causes motion and which of those elements will oppose the motion. I write those equations and then how to unwrap. So sometimes that critical thinking that I talked about is all it takes for you to solve a problem. Now here, let's say this bump causes this. So wants to go up, this spring doesn't want. So this is road, that's not my system. This is car, this is my system. And I'm gonna use my system, right? So free body diagram for M1 would be, I'm going to have a force, right? That doesn't want to move, wants to go straight, so doesn't want to get anything from the environment. So here your input is kind of a disturbance, if you think about it, right? It's an input, but still something you don't like. So it's KW of some displacement, right? So the displacement is, so X and Y are your position at equilibrium. Your car was moving, so the lower part is your wheel, the top part is the chassis. So you're moving and both of them are holding their position, X and Y. Then you hit the bump. So you start moving from here. Since both of these place X and Y at equilibrium, we can eliminate gravity. The gravity was applied, right? It's not going to have much effect. So, or you could just also assume an would have been fine, but you can eliminate gravity in this case. So you're hitting. So the K omega KW is going to have a displacement of X minus R, right? Because they are relative displacement. So I'm going to say this is X minus R. So this is what caused the system to move. Now, for M1, the other element, which direction their force will be applied. So what do we have right above M1? A dash pod and a spring, right? These two wants to oppose
the motion caused by k omega, right? Since that's down, these two are up. So this one now is, this displacement is because this is between these two. So we have B, let's say x dot minus y dot, whichever way you want to say. This one is ks x minus y. Nothing else is applied on it. If you want to count gravity, you can, but since we start equilibrium, when you have your springs in vertical motion, if the spring is the cause of motion, you can't neglect gravity because gravity is not going to add anything to it. Yes. So, yes. The car is moving in this direction, right? V car here. So at equilibrium, you had both of these were at their zero. This is your wheel. Well, your wheel is here, actually. It's going in the car. So this spring is kind of modeling that wheel for you. So you want to go straight. You don't want to change elevation, let's say. You want to go straight. Now the bump wants to push you up. So the car wants to keep going down. So the role of this is that wants to go down, doesn't want to have that displacement. That's why it will be downward. The car wants to stay on the same elevation as it was going. So now, once I have that, if you want to show mass 2, so this was the direction of your x. This is y. What are the forces applied on mass 2 and what direction?
Down,
Which one?
the.
Yeah. So just opposite direction, right? Same as dashboard, because these two will be the forces applied to your M2. So think about it, on top of the car, it doesn't have anything else applied to it, right? It's the chassis. It's a hit, makes that displacement and keeps going. So, so in this case of a car, this disturbance, this motion is generated from the bottom, right? And the car wants to stay down, doesn't want to go up. It's designed not to go up. So so the first force wants to go against the applied force, right? So let's say that this was your applied force, R of t, if you want to think about it, then this guy doesn't want to go with that. Now that I'm here, how do I write the differential equation? From here should be easy, right? You could show also the inertia. I didn't because some of the students didn't like that way. So let's say for one, sigma f is m1 x double dot. For the other one is sigma f m2 y double dot. And then we have the positive direction of x. So this is negative k omega x minus r. Now to your question. If you see the other way up, then you have to, then the other two forces will go down. So there would be a negative applied to everything. So it would push it up. But if you would stay consistent with the direction you get, even if you're wrong, so let's say you say that k omega x minus r is coming upward, and the other two will come downward. And then we take the negative. But it will fix itself. This is consistent. So negative k omega x minus r plus b x dot minus y dot plus ks x minus 1. That's for the first one. For the second one, we have they are again in the same in the negative direction, opposite direction. X minus y minus b x dot minus y dot. So bring these rearrange them on one side, right? So your r here, what is your r? Here, What is this R? Your input, right? That's your RT that we show down there. Because it can change. How is that R? So if you zoom here, this is like that. So with time, this R changes until it reaches this normal value. So we can say it's RT. Just a different distance, right? Now, I find my differential equation from here. What's the order of my system? Second order. So I have two second order system. How do I write a state variable equation for this? Yeah, you change variable, and then you know that it's gonna be a 4x4 A matrix. The rest of it just follow the other example we had. So you see that always the system is the problem. Like, okay, how is my system acting? Once you know free body diagram, write the equations, and then just follow the procedure, get your state variable. After that is the same. Just that first part, how do I write or how do I show that free body diagram? So this is a more like practical application kind of question. It's not going to show up in your exam, something like this, a comment. It's not like this. It's like something you saw in your homework. But it doesn't matter. To my eyes, you should be able to solve this. But this needs a little bit more thinking. How do I apply my knowledge? Does that make sense? Right? Okay. So, any questions? Yes. Okay. So how many systems do you have? There's two equations for this one, two for this one. So you will end up having z.1, z.2, z. I will post the solution. I've written it. And then this is 4x4 plus, don't forget the BU, and your U is RT. Right? And you'll see that R only showed in one of them. So it's going to be 0, 0, 1, 0. Another question, I saw a hand.
When you're asking for equations, if you don't just read it format, but you want it better, or would you like?
At least rearrange them to, okay, I'll write what I would, for me would be acceptable. M1 x double dot plus k omega r. And I'll tell you why, because this is going to be input, so you can put it the other way. Plus, let's say you can write, keep it as this. Then you say, okay, this was my input. Move that to the other side. So you show me you understood what is input, and this is the rest of the equation. So this is good for equation of motion. But to be able to do the second part, you actually have to separate them, right? Properly. But for equation of motion, if I ask, as far as you sit the system on one side, the input on the other side, I'm fine. Sounds good? All right. Yeah, study over the weekend. I would not be able to answer your email, but I'm available on Monday. So if you have a question, you can come to my office, send me an email. I don't know Brett's schedule, but he'll be available too. All right. Good luck. Have a good weekend.